Welcome back to our course in college algebra. I wanted to make another video talking about graphing absolute value functions. Now, in the last video, we introduced the concept of transformations of a graph. In particular, we were talking about shifting a basic absolute value graph. So remember, if you see a function that has taking absolute value as part of the rule for the function, expect a V-shaped graph. Now this is the most basic absolute value function you can get, y equals absolute value of x, and we've got this V shape right here. Now I want you to compare this to the graph of y equals x. Okay? I'm going to draw it here in orange. Try to get the same scale and everything. So y equals x would look kind of like this, okay? So the right-hand side of this graph looks identical to the right-hand side of the graph for y equals absolute value of x. Now on the left-hand side, there's going to be a difference. Okay. This is the graph y equals x. It's a linear function with slope 1 and y-intercept 0. Okay? So I want you to notice what's happening here. When we take the absolute value of something, well, we know absolute value is always going to give us a positive outcome. Okay? So to go from this picture over here on the right to this picture on the left, it's like we have taken the left side of the picture and reflected it about the y-axis. Okay? So if I were to reflect this up, kind of giving the mirror image, okay, instead of going 1 unit below, we're going 1 unit above. Instead of going 2 units below, like we are here, we're going 2 units above. Okay? If we do that, we get what we have over here. So when you deal with absolute value functions, you can look at what's inside and think about graphing that. Whatever was below the x-axis needs to get reflected above after you go to the absolute value function. Okay? So let me give you a specific example. I'm going to draw the graph of f of x equals absolute value 3 minus 1/2 x. All right. So here's what I'm going to do. I'll do this. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3. Okay. So for some scratch work, here's what I'm going to look at. What I'm going to look at is the graph of y equals 3 minus 1/2 x. Okay, so in other words, for scratch, I am ignoring the absolute value function. Okay, now, this is a linear function. Y-intercept is 3, 1, 2, 3. Slope is negative 1/2, okay? So slope is negative 1/2. Over 2, 1, 2, down 1. Over 2, down 1. Over 2, down 1. 1, 2, 3, 4, 5, 6. Okay, so linear function, slope negative 1/2. All right, now, I'm taking the absolute value of this. Now let's think about what the absolute value operation would do to a graph. Well, taking the absolute value gives you the positive version of whatever you started with. Okay, so when my y values are positive, there will be no change. Okay, so if I'm graphing 3 minus 1/2 x in absolute value, well, this portion of the graph is going to look exactly the same as I have right here. Okay, so 1, 2, 3, 4, 5, 6. 1, 2, 3. So this is going to be a line with y-intercept 3 and slope -1/2. Now, over here, in this portion of the graph, well, if I take the absolute value of this, I would get the positive version. Okay, so on this side, we're going to reflect, instead of going below the y-axis like this, it's going to be going above the y-axis. Instead of having a slope of -1/2 over there, it's going to have a slope of +1/2. Okay, so it's going to look like this. All right, so this is the graph, absolute value 3 minus 1/2 x. So if you can get the graph of 3 minus 1/2 x, which we know how to do because it's a linear function, then you can use that to get the graph of absolute value of 3 minus 1/2 x. What you need to do is figure out where the y values would change from positive to negative. If the y values are negative, then you need to reflect across the x-axis. You need to do a vertical mirror image because the absolute value function is going to take your negative y values and change them to positive. Right? This point, 8 comma -1, is on the graph of the original function. This graph should have the point 8 comma +1, not -1. Okay, so graphing with reflections, what you need to do is ignore the absolute value just for a minute. Okay, figure out where this graph has positive y values, figure out where it has negative y values. Wherever it has negative y values, take that portion of the graph and reflect it across the x-axis to get the graph of the absolute value function. Okay, so we have two tools we can use for graphing absolute value functions. We have transformations, and we have this idea of reflection.